first one is a sequencing problem. So basically, what you're gonna have to do is create a sequence based on this right here. So just like we've done in class, right? We had a sequence, and n was the number of, or whatever current value we were on, and based on, like, say n was 4 in this case, then it would be at n minus 2 would be our sequence at 2, at n minus 3 would be our sequence at 1, n is whatever position we're at in the sequence, and j at n minus 1 is our position at n minus 3, or n minus 1, right, which is at 3, in this case if we had 4. So the idea is you put in a vector that's 3 long, user input, and you calculate, let's just say j4 like I just said, with these 3 inputs. So like I said, j sub 4 would equal j sub 4 minus 2, so j2, minus j sub n minus 3, which is 4 minus 3, which is 1. So it'd be 1 minus 0, which is 1, times 4 plus 2, which is n minus 1, and that would give us 6, right? So that's how the series works, or the sequence works. And based on that, what we do is okay, now we define j4, we'll store it in the next value. And then after that, our n would then be 5, and we would just basically do the same thing, but with starting values that are each 1 plus 1, right? Because n is now 5, not 4. And so on. Up to, this one goes up to 6. But the idea is you use that sequence to create a sequence of however many values we tell you. So n in this case is going to be the number we count up to. So j sub 6, j sub 10, j sub 20, whatever you need. In your other input's going to be a 1 by 3 row vector, right? Because we need at least 3 values to start this sequence, because like we say, n minus 3, right? So we at least have to have 3 starting values. Function header is the same as always in your MAs, so we have to have a specific format for it. So what I'm going to have you guys do is just work on this first part right here, just creating this function with this sequence. I'm going to give you guys about, let's say, what do you guys think, 25 minutes, 30 minutes? I just don't want to take everybody all day for everybody, but if you guys feel like 25 minutes is good. Sure, yeah. If we don't want to take all day, sure, that's fine. So we'll do 17. We'll meet in the middle there. So 17 will work. Um, just work on this first part, function part. If you want to work ahead, feel free. But after 17 minutes, I'll stop you guys. We'll go over this part, and then we'll do the next part, the main script, and then that's it for this problem, and we'll move on to this problem. Cool. Awesome. So I'll just sit here. I'll treat it like a mock exam. I can only answer questions about the prompt, not how to do things, until we get to that second section, right? So just try and work by yourselves, treat it like an exam, and then once we go over it, we'll go over it. Okay, cool. So, like I said, the idea is you have a sequence, right? You have a sequence, and let's say n is number 4, right? So the fourth value in our sequence, j sub 4, is going to be equal to j sub 4 minus 2, which is 2. So we would use 1, minus j sub n minus 3, so 4 minus 3, which is j sub 1, so 1 minus 0, times n, which is 4 in this case, right, because we're looking at j sub 4. So times 4, which is 4, and then plus j sub n minus 1, so 4 minus 1 is j sub 3, which is 2. So that's why our j sub 4 is 6. So that's kind of how the sequence works, and you would just keep repeating it. If j was now 5, you'd imagine we wouldn't use j sub 2 here, right? Because our n is no longer 4, it's now 5. So we'd use j sub 5 minus 2, which is 3. So as we increase what n is, we change what values we're using in the sequence to create the next value, if that makes sense. So the idea was we wanted to create a function that basically took a starting row vector, a 1 by 3. So user input, user input, user input, and then a number of values for the sequence, so whatever our last value was, and then outputted the final sequence. Okay? So let's go ahead and pull this up. I'm just going to start with the function itself. So we need a function, we need our outputs, and then we need jj underscore, put my cougarnet, and then our input. So our input's going to be, okay, maybe I got to use something else. I'll just use jj here since I've already used that function name before. So what we're going to need is the starting row vector and the number of values in the sequence. So I'm just going to put jj sequence here, and then I'll put, let's go ahead and just go n, right? Okay, so those are our two inputs. Our output is going to be the finished sequence, so I'll just call it JJ sequence again because that's what we're going to be putting out. It's just going to be updated in the function. So okay, so we know the first three values in JJ sequence are is 1 by 3, right? Now let's talk about how we're going to get J sub 4. We'll just think about it as just J sub 4 right now. So let's say J new. So this is J sub 4. Let's go ahead and call it. So what do we need to do? I'm going to go ahead and throw the prompt next to this. You guys can still see this fine, right? Cool. Okay. So our equation here, let's think about this as J sub 4. Okay. So J sub 4 minus 2 is J sub 2. Right. So we would index JJ sequence at 2. Right. And it looks like there's a couple parentheses there in that equation. What we'll do is now subtract J sub n minus 3, which is 4 minus 3. So JJ sequence at 1. Right. And then what we'll do is close that subtraction, multiply by, in this case, 4, and then plus JJ sequence at n minus 1, which is 3, right? Because we're on 4 still. Okay, so that's how you calculate J sub 4 with 3 starting values in your sequence, right? Now the issue is we want to be able to do this for however many times we have a new J sub n being calculated, right? So if we're going to do this for a finite amount of times, not for a condition, we need to use a for loop, right? Because a for loop runs a certain amount of times and it stops. The while loop has a condition, so we do need to have some kind of condition for this, which doesn't make sense, right? Whenever you see a sequence, whenever you see something that needs to repeat for a certain amount of times, then that's going to be a for loop. Whenever you see something that's like, okay, validate that the user did this, that's going to be a while loop. So we'll start with a for loop. So we'll need a variable for our for loop. I'll just go ahead and use I. And so where are we going to start? If we start at 1 here, what problems do you think we're going to run into? Right, so if n is 1 to start with, then we'd have 1 minus 2, which is negative 1. And we can't index something at a negative index, right? So the whole idea here is we have 3 starting values. That means we know the first 3 values in our sequence. So we're automatically going to start with the 4th value, right? So that means this has to start at not at 1, but at 4. Cool? So now how many times are we going to go through this? How many times do we want the loop to repeat? So there's n, right, there you go. So yeah, so just boom, right there, because we're counting all the way to j sub n, right? Cool. So now whenever we see a 4, I'm going to go ahead and change it to I. In this case, we don't have to worry about it. I'm just going to call this j sub new for now. So that's just the new one we're calculating every time. Now, imagine if I was 4. To get to 2, we'd have to go I minus 2, right? 4 minus 2 is 2. Does that make sense? Okay. Now, if we wanted to get to 1, we would have to go I minus 3, right? Because we need the third one. Or the first one, sorry. And then JJ sequence at 3 is I minus 1, right? Because that we were at 4 originally. That's how you can kind of think of it to kind of replace your indexes with the for loop indexes instead of just like, starting like with just the for loop itself and trying to think about it as it continuously changes. Um, and then now, of course, we'd have to change this 4, right? We want it to be n, whatever n is in our for loop, right? In this case, it would be I, right? Because I changes by 1 every time we run the for loop. Cool. So that's the new value, right? That's if I is 4, that's j sub 4 right there, and stored in j new. So in order to just finish this up, all we have to do is say jj sequence. So our input, the first 3 values we had, becomes itself, but then we'll just add j new to the next column, right? It's a row vector. So you'd have something like that right there. That is us adding that 6. That's what this line does right here. Cool. And then now that we know that j new changes every time I changes, we now know this is automatically just going to keep running until we hit n, however many we want. So that's it's basically it for this function. Do you guys have any questions? Anything I need to clarify on? Okay. hmm Right here. Okay. So the idea is we have some kind of sequence, right? We have some kind of mathematical equation, and you were able to do that with J new, right? But the idea is we have some value n that is going to be the last number of j's that we have. So if n is 6, we'd only calculate up to j sub 6. But the idea is n has to continuously increase, right? So if n starts at 4 in this case, because we already have 3 values, it runs with these based on 4 minus 2, 4 minus 3, 4 minus 1. Then after that, once it calculates j sub 4, n increases by 1 to 5. So now we calculate j sub 5, but at 5 minus 2, 5 minus 3, and 5 minus 1. So the idea is we're using these 3 values to calculate j4, but then we calculate j5, we're now using these 3 values, j2, j3, and j4, because we increase n by 1, and those subtractions don't change, right? We're still subtracting n minus 2, n minus 2, but n is continuously increasing all the way up to 6, if that makes sense. Mm-hmm. Yeah, so we calculate the fourth value first, but then what if n is 6? That means after we calculate the fourth value, we then calculate the fifth value and the sixth value. That's what the for loop does. Because it counts all the way from 4, we start with the fourth value, all the way to however many values n we want to finish with. Yeah. But the key thing here is, like, it's kind of confusing to think about j sub n. This really should be the value of the sequence. I think this should be I here, not n. It's kind of confusing because n is like you got to think about it as your last value and also the current value in the loop. If you think about this as just instead of seeing n's, you see i's, it makes more sense because you're just counting from I equals 4 all the way to n, which is the last value you're going to calculate. Yeah. Just imagine how the n's are there, but instead it's i's and I counts all the way from 4 all the way to your n value, whatever that is. Cool. All right. And then this last line is simply just taking whatever sequence we had before and then adding whatever j new we calculated to the end of that sequence. So there's the timer. Okay, so the idea was we have main script now, right? We have to use our function in the main script. Um, we want to ask the user to enter the total number of values to be created for the sequence and store this in a variable named num. Okay, so it is assumed that the value is positive and greater than 3, so we don't have to even worry about validating this. So simply, it is, do the same thing I did last time. Simply, we'll just add our housekeeping commands real quick. Boom, boom, boom. Okay, so we want to use num, and that's going to be an input statement, right? We're asking for something from the user. I think it's enter the length of the sequence to be generated, right? Boom. Okay. We don't have to do anything else there. Simple input statement. The next is going to be ask user to enter the 1 by 3 row vector and store that vector in the variable named start. Okay. So we're going to say start is equal to another input statement, right? And we're going to say please enter a 1 by 3 vector to begin the sequence, right? That's all we got to do for that. But now we have to validate start, right? We want to check that, like I said before, check that it's a 1 by 3 vector. So we can't use length here, right? Because if I used length of start, what does length return? Does anyone remember? So it's the number of the greatest dimension. So let's say I still have a matrix, right? But the matrix is 20 rows by 2 columns. Then it'll return 20. If it's 20 columns by 2 rows instead, it will still return 20, right? It'll only return the largest dimension. Okay? So imagine if we had 3 columns, which is what we need, right? We need a length of 3. But what if we had like 2 rows? Then length would still return 3 even though we had 2 rows, which is wrong. Right? We want only a 1 by 3 row vector. So just make sure you use size here to make sure it's a vector. We've seen this before. Rows and columns equals to size of start, right? That's how we use the size function. Now our while loop, because we want to keep asking until we enter something valid, so it's going to be a while loop. It's a condition. While r, and hold on, I don't have the tilde key on my computer or on my keyboard, so I gotta paste it. So while r is not equal to 1, right, because we want 1 row, or c is not equal to 3, right, because we want a 1 by 3. So when it's not a 1 by 3, we have to keep asking, right? So in this case, yeah, just give me 1 sec. Let me wrap this up real quick. So throw this here and then end. Okay, what's your question? So it depends on what you're doing. So inside of a condition, so for while loops and if statements, you're going to want to do a double. In logical arrays, you do a single. So if I had like a logical array L was equal to where some vector is greater than 3, I would use a single here. Vector is less than 2. Okay. But the good thing is if I run this, it won't error if I have a double. But if I have a single, I believe it will error. It's safe to put 2. It actually didn't error, which is interesting. Oh, because I had a 1 by 3. Um, it's always safe to put 2 in the while loop and if statements. Yeah, just make sure you do that. But did anyone have any questions about the while statement? I mean, it's you just ask for the start, check the size, make sure the size is a 1 by 3. If not, go ahead and ask again. The key thing I want to remind you about here is that you always want to have whatever variables you have in your while loop condition, you always want to have them inside of your while loop. Okay? That means we've defined R and C outside of here, right? But then inside the while loop, we redefined it again. If I wasn't to redefine this, but ask for start again, R and C don't change, right? Because they were defined up here. So that means our while loop's just going to keep running on those same R and C values no matter what start we enter, which means our loop's never going to end, right? So the key here is you always want to make sure that whatever variables are in the condition for your while loop are also inside the while loop. They can be changed inside the while loop. So that means you can eventually break the while loop and get out of it. Um, so cool, awesome. So that's user inputs and validation. Sequence creation. So simply that's just calling I'm gonna call it sequence, and I'm just gonna call my function. Oops, I spelled it wrong. Yeah, cool. And if I open the parentheses, we should see that it wants JJ sequence and length. In this case, start and num, right? No, you don't. When you call it, so the brackets are gonna be how you define the function. This is how you say, like, I'm making a function called JJ that has the inputs of JJ sequence n and outputs of sequence. But in this case, now what I'm doing is I'm saying sequence becomes my function with these inputs. So it basically becomes the output of my function. Yeah, cool. So that will give us our sequence that we need, right? Now it just wants you to save it, right? So you can simply just use save. And remember how if we open up the parentheses for save, we'll see it needs a file name and the variables. So file name, says there exam2 underscore your CougarNet, and then, or no, sorry, sequence, and then it's a .mat file. And then for the variables, just remember you have to actually put them in strings here. So make sure you use apostrophes here. That's just how save works. Can't really tell you why, but that's just what it needs. So just make sure you have these in apostrophes instead of just like the name itself, the variable. You just have the name of the variable in apostrophes. It's just how the save function works. So cool, but that's saving it. And one thing I want to remind you here is that save cannot be used for all data types. Okay. Remember how if we want a CSV file, CSV write, right? We use CSV write instead of save. That's just something to point out just in case you see him, instead of say save a mat file, save a CSV, just know you have to use a different function there. And it's basically the same thing. It'd be CSV write file name. So we need exam2 underscore sequence and then dot CSV because it's going to be a CSV file. And then M in this case, now it doesn't need the apostrophes. So just small things like that. The good thing is you can always look these things up, right? CSV write. If you click on this, writes a matrix file M. So a matrix M to the file name, file name. So a matrix M means it needs to be numeric data, right? So you can just quickly look that up. Click on M, it needs numeric data, meaning we need the actual variable there, not the variable name and apostrophes. You can look up what I mean. It's an open book to open note test. So, like Dr. B says, the only thing you can't use is somebody else's help. You can look up all your notes. You can look up all the class notes, whatever you need to complete this. You just can't get help from somebody else, like physically next to you, telling you what to do. We're like communicating with you. Yeah, I mean, but you wouldn't want to even Google it. You could just use mean. Click on that, and then say, okay, mean of A returns mean of elements A along the first array dimension whose size is not equal to 1. So if A is a vector, then mean of A returns the mean of elements. And if you need to know what A is, input array. It'll tell you what it can be. We'll move on. Now we'll move on to the repeat and store. So using a menu, ask the user if they would like to create a new sequence with the same number of elements as num, but with a different starting 1 by 3 vector. Okay. So first we'll start by defining a variable repeat, and we'll use menu here. And it seems like, what did it say? Would you like to create a new sequence with a different starting vector? Cool. Oops, I forgot my options, right? Yes and no. Cool. So we asked them that, and what we're gonna have to do is throw a while loop on top of this now, okay? So the key here is, where do we want to throw the while loop? We want to throw it on top of where we define the starting vector, right? Because we want to enter a new starting vector every time, but we want to keep num the same, right? Same number of elements, num. So right here is where we'll put the while loop. So while repeat equals 1, meaning we said yes because it was the first option in our menu. If we click that, it would store 1. Click a no, it would store 2. X stores 0. So if we click yes, which means 1, we repeat, right? Mm-hmm. Yeah, so if I go ahead and copy this, paste that, it's going to pull me up a menu. If I click yes, repeat is going to store um, a 1 because I chose the first thing. If I go ahead and go here, no, repeat is 2. If there was a third option, it would be 3. But then the thing is, if I click out of it, it'll store 0 because you didn't click an option. Cool. So now the thing here is, now we have a while loop on top of our code that repeats whenever repeat is yes, right? But we have to remember, we have to first define repeat to be 1 to start. Because if you imagine, if we start our code, close clear CLC, whatever, we ask for num, then we don't have this guy. While repeat is equal to 1, it doesn't know what repeat is yet. right? Because we haven't ran the loop yet. So it's going to error, right? Because it's going to say, well, what is repeat? We don't know what that is. So if you set repeat equal to 1, then it first pre-allocates repeat equal to 1. So it forces this while loop to run once, right? Because repeat is 1. Then once it runs once, we run all our stuff, we validate, we calculate our sequence, we save it, blah, blah, blah. It asks for repeat to be redefined inside the while loop. Like I was saying before, you always want to have whatever is your condition in your while loop, repeat, inside of your while loop that's changing. Right? You want to have an option to change that to make sure your while loop actually can break. So the whole idea here is we just threw a while loop on top of whatever we wanted to repeat. We threw repeat inside of the while loop to make sure the user could choose. And then we pre-allocated the start before we get into the while loop just to make sure it runs at least once. Because once you're inside the while loop, it doesn't actually get to these lines, right? It just keeps running what's inside of it. Okay, so store the new sequence in the next row of the variable named sequence. Okay, so it looks like sequence. I'll go ahead and change this guy to sequence. So this is just simply the sequence I developed. I'm just quickly changing these guys here, the name of what they were. That's all. Okay. So now we have sequence. We want to store the next one in the next row of sequence, right? So in order to count how many times we've done this, we need a counter now. So if I say count is equal to 0 here, and then I say count becomes count plus 1. What this does here is imagine running your code the first time, clear close CLC, ask for the number, repeat becomes 1, count becomes 0. We run the while loop the first time. Count becomes count plus 1, count is now just 1, right? 0 plus 1. Then if I go ahead and say sequence at count, comma, all columns becomes the output, this actually stores whatever vector we output. So let's say it's just these four right here. It stores this vector right here, 0, 1, 2, 6, into sequence at count all columns, meaning at 1, because it first starts at 1, all columns, right? So it just stores it in the first row. Then let's say we repeat, we run again, count becomes count plus 1, count is now 2, and so we store it in now the second row. So every time we run this, we're basically just going to the next row of sequence and storing the vector in there. Keep repeating till the user selects no. The number of rows of sequence will be equal to okay, cool. So that's basically it. Did anybody have any questions about that count part or the menu or the while loop? Awesome, cool. And I'll make sure to get this code to you guys. I'll go ahead and put it in the Blackboard or in the Discord. I don't think you guys have to actually submit this, so we'll make sure that you guys have the solution code for this. But now it's about 2:30 or it's 2:16. I'm fine to keep working with you guys. We're gonna go ahead and move on to the next problem. But if you gotta head out of here, remember I am recording it. So yeah, so I'll go ahead and talk to this next problem we're gonna work on. It's a moving window problem. So create a function named. Sure. What's up? So the idea of this second problem is create a function called change column that looks through a column of matrix and creates a final matrix that stores the positions of the change values, index 1 in column 1 and modified values in column 2. So, for example, if we have, I think I have it somewhere over here. Yeah. So let's say I want a 10 by 10. Don't worry about this. This is a little later. But say I have this matrix here. Okay. Say this was our random matrix we wanted to look through. I want to look at column 6, and I want to basically change some values in this column, and I want to keep track of what I'm changing, right? So let's just say, let's say we work on column 1. So let me just delete all this. Okay. So say we just work on this column right here. Imagine these rows are no longer, these columns are no longer here. And we only want to look at this guy. We're going to change this guy. So in this case, let's look at the prompt. If the first value in new call is not the smallest value, replace it with the minimum of new call. So if new call is this guy, if 5 is not the minimum value, it looks like 3 is, then we'll replace it with 3, right? That means we changed the first value in 6, right? We replaced it with 3. So what it wants you to output here is not that changed matrix, not that matrix with 5 replaced with 3 or and whatever else we do. It wants you to output the row at which the number you changed is. So in this case, we changed 5. It's in row 1. So I want to store that it was in row 1, and I want to store that it was 5 to begin with. So that's what you'd output. So for example, put this up. If I have this matrix here, it's a 6 by 5, and I want to look at, um, what is this saying? I want to look at 2, 3.5. I want to look at, hold on, new call is 2.5. I think this is different from what it was. But basically what we did is we looked at the column, and let's say we changed, like we did the 5 to a 3. We would store 1 here, meaning it was in row 1, and we'd store 5 here, because it was previously 5. And the next condition looks like if the last value in new call is not the largest value, replace it with the maximum value. So we go back to that column 6, that's the one we're looking at. If the last value, 9, is not the greatest value, looks like 10 is, that means we replace 9 with 10, meaning the next value in our output matrix would be the last index, which looked like 10, so it would be a row 10, and the last value was 9 that we replaced, right? So I want you to keep track of the row of what item was replaced, and then the previous value that was replaced, if that makes sense. Okay, that's what it wants you to output, but depending on these conditions. So these are the conditions that are saying, okay, this is what you would change if these conditions are true. Okay, so firstly, what I would do is attack this like you're trying to just do this stuff, right? You're trying to get that column, and you're trying to say, okay, I need to replace the first value to minimum, I need to replace the last value to maximum, I need to do this next thing. Once you figure out how to do that and get all that working, then we'll move on to storing the actual the values there, right? What I just talked about, what we were outputting. So that's how I would attack this. I'll give you guys about 15 minutes again. Maybe I'll go over this part first and give you another 15 for the next part because it's a pretty beefy function, but we'll walk through it after this. So I'll give you guys about 15 minutes and then we can go on and talk about it. So the idea of a moving window is that you have a window of values that you kind of you perform certain operations on. Oh, thank you. Appreciate that. There we go. Okay. So the um the idea of moving window is that you have a window of values. So this is our matrix. In this case, we're pulling out a column. So that column is our window of values that we're going to perform certain operations on. Okay. But all in all, let's just kind of follow the prompt. So function, we need a function called change column. Our output is going to be the final matrix. So I'm just going to call it mat, and we're going to go change column here. And our inputs are going to be the start matrix and column number to store and change. So you know what? Let's just call this uh, imat, and we'll call this call. Okay, cool. I used imat and call. In this case, their starting matrix and the column number to store and change. So I just call them whatever I want right now, but we'll go ahead and I just call them kind of something relevant to what they were going to be. So, like I said, firstly, let's work through just what it tells us to do. Let's not worry about creating this final matrix yet. Let's just worry about like what it tells us to do right here, which is first pull out the specific column as its store in new call. Okay, so new call becomes imat at call. Right, imat is our initial matrix, something like this guy, and call is the number of the column we want. So if its call is 4, we pull out this guy. Right. Oh, but of course, did forget, we need to go all rows. Right. We want to get all the rows at the specific column that we want in the matrix. Awesome. So now what we need to do is if the first value in new call is not the smallest value, replace it with the minimum value of new call. Okay. So that's an if statement. You see the word if in there. If the first value in new call at 1, need my tilde, is not equal to the min of new call. Right. If the first value in new call is not the smallest value, if not equal to the minimum, then replace it, right? So we just say new call at 1 becomes min of new call, right? Simple. Next, what we're doing is if the last value in new call is not the largest value, replace it with the maximum value. So basically same thing. New call at end does not equal max this time of new call. Then new call at end becomes max of new call. Right? That's just what it's telling us to do right there. Right? We just want to replace the last value if it's not the maximum. We're going to replace the first value if it's not the minimum. Cool, cool, cool. Yep. Okay. So now, for the remaining values, do the following check. If the current value is not greater than or equal to the previous value, the row above, or not less than or equal to the value of the next row, row below, replace the current value with the average of the value located one row above and one row below. So the idea here is you have some kind of column. You have some kind of, so let's just say, let me just do this real quick. So I'm just going to give us a vector real quick to look at. Okay, so this is our column, right? Pretend this is the column of values, right? So what we did is we replaced 8 if it wasn't the lowest value. So in this case, what we've done so far is boom, we replaced the 1, right? And we replaced this if it wasn't the highest value. Highest value is 8, so boom, we replace that there, right? That's what we've done with these two so far. Now the idea here is we want to take a look at all the other values, so these guys in between them, and we want to see if, let's say for example, this guy, if this guy is sorry, if this guy is not greater than or equal to the previous value, row above. So is 8, if 8 is not greater than or equal to 1, or not less than or equal to the next value, or if 8 is not less than or equal to 4, then replace the current value, 8, with the average of the value located above and below. Okay, so if one of those two conditions is not met, we replace it with the average of the one above and below. So for example, if we run 4, we test the conditions for these two numbers, and then if it doesn't meet one of those conditions, we replace it with the average of 8 and 7, and so on. Okay, so that's what that guy says. So we know here that we have to look at a value, and we have to look at it. We have to look at a value one row above and one row below, right? Because that's what the condition depends upon. So that means we can't start at 1, right? Because if I start 1 here and I try to look one row above it, there's nothing there, right? So we'll get an error. So what we have to do is start at 2, right? There has to be one above and one below. Now if I were to go all the way to the end, I wouldn't have one below, right? Because we always have to go to the number we're at, look at one above, one below. Can't go there because there's nothing there. So I'd have to stop here. Okay. So that means, like we said, whenever something happens like that, we have to have a for loop, right? I equals, what do we start at? We don't start at 1, right? Because we don't want to start here and try to look above it. We want to start at 2 here. So for I equals 2 through, do we go through 9 here, or do we have to do something with the length of our column? Yeah, so it wouldn't be end minus 1, right? It would be length of new call minus 1, right? Because if we were to just go new call at end minus 1, what that would do is it would pull out 8, the actual value 8, and subtract 1. So it would only go to 7 here. But we have 10 values, right? So we want to make sure it goes to the length of new call minus 1. So it'll go to 10, which is the length of new call, minus 1, which is 9. Cool. So now that we've done that, what we need to do is test the conditions, right? If the current value, so new call at I, is not greater than or equal to the previous value. So not greater than or equal to means just less than, right? Not greater than or equal to, that means it has to be less than, right? So if it's less than the value above it, so new call at I minus 1, right, above it, one row above, then we have to run this equation, right? We also have to have the or, right? Or if new call at I is not less than or equal to, which means greater than. right? Not less than or equal to, has to be greater than. Then if it's not greater than the next value, so new call at I plus 1, then we have to do something, right, inside our if statement. We have to replace the current value with the average of the value located one above and one below. So we would just say new call at I becomes mean of new call at I minus 1, comma, new call at I plus 1, right? And I'm going to go ahead and put brackets around this so it thinks it's a matrix. And then boom. So that's the idea of all the conditions, right? That's just getting the conditions done here. We've done this part. We're not keeping track of where we change things and what values were changed, right? Because remember, that's the whole idea of this function. We want to keep track of what was changed. But now we've just, what, sure. Yeah. So basically what I did here is I created a vector. So let's say I create a vector v that is new call at I minus 1, comma, new call at I plus 1. Right. So what this is right here, this vector is the values above and below whatever new call at I is. So let's say I is, let's say 3 somewhere in here. Then I is going to be equal to 3. New call at 3, which is I, becomes the mean of new call at 3 minus 1, which is 2, which is 1 above it, and 3 plus 1, which is 7. So what we're doing there is just creating a vector, v, that contains this 8 and this 7. And then what we're doing is taking the mean of that vector. So instead of doing this, what I could have done is just this. Right, so I just kind of defined the vector inside of the mean function and then ran the mean function. But you can split it up like this. It's the same thing. I mean, you could also, instead of using the mean function, what you could do is just say, this might make a little more sense, at I minus 1 plus new call at I plus 1 divided by 2. Right, that's just taking the mean of two values. Yeah, so that's basically what we're doing with the mean function there, but we're just using the mean function instead of actually, there we go. Yeah, you can do that way as well. But yeah, so now we've actually done what it wants us to do, right? We've changed these values, but now we need to keep track of where we changed these values, what the values were, and what row of the column we changed. Okay? So first things first, we know we're going to have to count how many times this happens, right? How many times we change something is going to change the number of rows we have in our output, right? Changes. Because if I change 3 different things, I'm going to have 3 different rows that occurred upon, right? So what I'm going to do here is I'm going to go ahead and define a counter. I'm going to say count equals 0 here, okay? Now imagine our first value in new call is not equal to the minimum. Then we would have to change it, right? So if we change it, that means we have to count that we changed it, right? So we're going to say count becomes count plus 1. This count will only count plus 1 whenever we find out that the first value in new call is not equal to the minimum, right? So now what we can say is we can go ahead and define changes. First, I'm going to define changes as just like something that's empty. It's just some random variable we just wanted to go ahead and pre-allocate. Just define it as just an empty variable. Then what I'm going to do is say now changes at count row first column. Okay, what this is doing is defining this guy right here if count is 1, right? So it's defining changes at 1 1 becomes whatever index we're changing, right? Because remember how the prompt said, um, where is it? Yeah, a matrix, the final matrix that stores the positions of the change values, the index in column 1 and the modified values in column 2. So that's why I can hard code this 1 here, and then I'm also going to have a changes count 2, right? Because column 2 is the second column. And we said 1 and 2. So now I know I have to put the index of where that change happened, which in this case, we can hard code a 1 here. The reason for that is because we checked new column at 1, right? This never changes. We're always checking the first value not equal to the minimum, meaning if this if statement runs, meaning it's not equal to the minimum, then we have to change it like we did down here. Well, before we change it, we have to make sure we figure out what index it was at and what original value it was, which was new call at 1. Right, we can hard code the 1 again because again we were testing the first value first. Does that all make sense? Cool, cool. And again, we're going to kind of do the same thing here with this one. So if I find out that the last value in new call is not equal to the max of new call, I have to add 1 to my count, right? Because I found some kind of change I need to make. So I have to count how many times I'm making this change. Changes at count becomes, or at count 1, right? We're defining that just like we did for the last time, right? Okay. The 1 and 2 again because we can always decide what column it's in, right? Column 1 is for the indexes, column 2 is for what value was changed. So now if I do this, what am I going to put here? What is the index of what I'm changing here? Does anybody know? Sorry, my video isn't on. Let me turn my video on. So the value of that index is going to be the last value in call, new call, right? New call at end, meaning the index is going to be length of new call, right? Because we looked at the last value. The length of new call is equal to whatever index the last value is at, right? Cool, cool. And so now the value, of course, is just new call at end that we're changing, right? Because this is what we're testing for. Basically the same concept of what we did up here. So those two are pretty simple, relatively simple to what we're going to do next. What we're going to do next is basically now we need to go inside the for loop and determine where we made those changes based on that whole less than, greater than the conditions we saw that I was talking about earlier. Let's remind ourselves of the conditions. So the conditions were if the current value is not greater than or equal to the previous value. Not greater than or equal to means if it's less than. So if new call at I is less than the previous value. The other condition was or the current value was not less than or equal to, which means greater than new call at the one below, which is I plus 1. So that's our condition there. If this condition is met, that means we're changing something, right? We have to change it to the average of the two values. So if we're changing something, count's going to become, again, count plus 1. Now, in order to decide what index the value being changed is at, where do you think we're going to do that? Right? We use 1 and end here. But now the for loop allows us to continually change that index, right? So what index do you think we're going to store? It changes at count, comma 1. Does anybody know? Right, you would just use I here, right? Because depending on what I is, we determine which values we're going to use, right? If the value at I, which is let's say 2 first, doesn't meet the conditions with these two guys, then we're going to change this value at I, right? So we're going to use I there. Cool. And then changes at count, comma 2 is the value that was changed, which is simply just new call at I. And that is basically it for our function there. Um, well, actually, so this again, lastly, we didn't define our output there, mat, and in this case, our output is going to be changes, right? Because changes was where we were storing all those indexes and changed values. This one's a little complicated. It's kind of weird in the sense you got to add that counter inside of an if statement instead of a while loop. But just kind of think about it. Like you run through your function, you define that new column, you set count equal to 0. If the first value is not if the first value is equal to the minimum, meaning that this condition is not true, then we just skip this if statement, right? Because it didn't make sense. It wasn't true. So if it's not true, that means we move to this if statement. Imagine that this if statement is true, meaning the new call at end is not the maximum. Then we add one to count, but we didn't add one to count here, right? So it would still start at 1, the first value in changes, right? The first row. That's fine, because again, it only wants us to count where we change things. Cool. So this is that's it for the function. There is a little bit of a main script. It seems like they just want you to ask the user for the dimensions of the matrix to be generated. Do you want it as a 1 by 2 vector? So something like this, like a 6 by 5. Yes, what's up? Mm-hmm. Okay. Mm-hmm. Um, so you use logicals instead of the if statement or instead of the for loop? Okay. Yeah, that could work. That could work. Yeah, so if you use logicals basically to um, determine if this happened or if this happened or if this happened, and you just kind of sum them up together. Ah, yeah, that works too. Yeah, so once you've done all this and then you just changed it and then you just yeah, you can do that as well. hmm That's actually maybe a little bit of a simpler way to do that for sure. It's a good idea. Yeah, yeah, no worries. Um, but the last part is just going to be a 1 by 2 vector, so the number of rows and columns you want your matrix to be. So if I enter 6 comma 5, see how we get a 6 5 here, 6 by 5. And I want you to create a random matrix with integers between 1 and 10. The dimensions provided by the user. Remember, we have a function for this. I know Dr. B's used this a couple times in class. You guys might not have used this in an MA, but you can use randi here, right? Returns, I'm sorry, randi, when you enter a size, returns a size 1 by size n array where size 1 and n indicates the size of each dimension. And Imax is the maximum number. And so also you can kind of like, so this would be a good example, Justin, of like where you could look this up, right? How to create a random matrix, MATLAB. Create arrays of random numbers. Um, so you see randi right here. So you're starting to see how to do it, rand. The randi function, double integer, discrete form, and it'll tell you how it works, right? So this is something, you can look up something like this. This is fine, right? Because the function isn't about creating that random matrix, right? We're just asking you to create one. So if you don't remember how to do that, you could just look it up, right? This is the same thing as saying like how to take the maximum of matrix MATLAB maximum elements in an array. It'll take you to the max function, right? So this is something you can kind of look up, right? But you wouldn't want to say like how to create the Joyce Jackson sequence, right? Don't look up the specific problem, but maybe look up tools you might need to solve that problem, if that makes sense. Yeah, cool. Um, so yeah, we asked for that. Like I said, use the randi function for that. Ask the user to enter a number between 1 and the number of columns. So this is for the column selection, and then you have to validate that the column selection is correct here with a while loop, and then apply the function. So those are the last few things in the main script. I'll give you guys 15 more minutes, and then we'll go ahead and wrap this thing up. Awesome. Okay, so the idea here is that we're creating our main script, right? So if it's our main script, and I simply just added on to the end of this one, but created a new section. So if you want, let's just imagine this is its own file. There we go. So let's imagine this is its own file. Same thing as creating a new section. So we want to ask for the size. Dim becomes input. Let's look at the input statement. Enter the dimensions of the rows, columns. Cannot type today. Awesome. Okay. And we want it as a 1 by 2 vector. We don't have to validate this though, right? We don't have to say we don't have to make sure it's a 1 by 2, right? It doesn't ask us to do that. So what we can do is just say create a random integers between 1 and 10. So I'll call it mat becomes Like I said, use the randi function. Our I max value is going to be 10. That's the maximum value you want it to be. Size 1 is going to be dim at 1. Size 2 is going to be dim at 2, right? Because dim stores our rows and columns. Cool. That might be the hardest part, to be honest. It's a function you guys aren't really experienced with yet, but it's really just all you have to do with it right there. I don't think you'd do something like this on the exam. I think it's just that they were using the randi function more that semester. So this is from the spring semester. Um, what's up? No, because size of dim will give you 1, 2, right? If I go RC equals size of dim, dim is always going to be a 1 by 2, right? If I enter 6, 4, and 5, RC, R is going to be 1, C is going to be 2, because there's one row and two columns. But the idea here is I want mat to be a 4 row by 5 column, depending on the values I enter here. Does that make sense? So instead of taking the size of dim, dim is the actual values of the row, number of rows, and number of columns we want to create this matrix out of. So 4 rows, because 4 is the first value in dim, 5 columns, because 5 is the second value in dim. But by taking the size of dim, remember dim is always 1 row by 2 columns, right? If I click on dim, it's 1 row by 2 columns. So it would always be a 1 by 2. It wouldn't actually use the values of 4 and 5. Yeah. Okay. So ask the user to enter a number between 1 and the number of columns and store this variable in the named column. So let's see what it wants. We use an input here. Enter a number between 1 and the number of columns, right? The number of columns. Okay. So in this case, to insert the number of columns here, we're going to have to use a function called sprintf. I'm not sure if you probably have experienced this in trying to make titles and stuff in your MAs. You can't just do this, right? Percent 0.0f and then put comma dim at 2, right? Because dim at 2 is the total number of columns we have. So from 1 all the way to whatever the dimensions of columns we had, right? We can't do that here because input doesn't work like that. You have to use the sprintf function to do this. So what I'm going to do is I'm going to say prompt becomes sprintf, and I'm basically going to do this, just copy this over. Okay, so what this allows us to do, it's just like fprintf. You know how with fprintf we have fprintf, it'll take whatever variables over here, put it in the percent where the percent sign is, and then print it out to the command window, right? Instead, with sprintf, what we do is we take this variable, we still put it in the percent sign where we want it to put it, but now instead of printing it out to command window, it saves it to a string. So for example, let me run this. If I go 4 by 6, what prompt stores now is enter a number between 1 and 6. And so what we're going to use that for is simply P right here. So now that becomes our input prompt. So if I do this, for 8 columns this time, oops, sorry, not P, prompt, for 8, enter a number between 1 and 8. So what it does is it creates that prompt for us by allowing us to use the sprintf formatting to put that variable where the percent sign is. It does that, creates a string out of that, and then puts that into as our prompt. Okay. So it's just basically because the input function can't actually do this right here. Can't put that variable in a percent sign. Okay. But now we've got that input statement done. We've got it working, right? So now we need to, if the user enters a column that is outside of the number of columns specified for under column, ask the user to enter another value. Keep asking the user if after the 4 attempts, counting the first attempt, the user not entered appropriate value, give a warning and set column equal to 1. Okay? So we have a certain number of attempts we need based on a condition, right? So we have to use a while loop here. Okay? Our condition here is that while column is less than 1, or column is greater than dim at 2. I'll go ahead and take this out because we talked about this before. Cool. Does that make sense there? That's our condition for it being outside of the number of columns. Not yet. Not yet. Yeah, we still have to do that. But this right now is just the condition for us to keep asking for a new column, right? It has to be inside that range. So if it's not inside the range, all we have to do is say here, just copy column and paste it in there, right? Inside the while loop, we want to have changing whatever is the condition of our while loop. Prompt doesn't need to change here because dim at 2 is always constant, right? We asked for it up here. We don't care about changing the number of columns anymore. We just want to pick a column inside that range of columns. So now we need a counter, right? This can happen in one of two ways. The way I like to do it personally is inside of the while loop with an if statement. We will do it that way first, and then we'll go ahead and try it the other way, like putting it on top of the while loop, like Justin was saying. So inside of this while loop, if count equals 4, then we're going to have to produce a warning, right? So just like we do before, we've asked once already, right? We asked for column in an input statement. So this time count's going to be 1 here. We're not starting at 0. We're starting at 1 because we've already asked once, right? We've already asked in that input statement once. So we start at 1. Then, if it doesn't meet the condition, we'll jump into the while loop and ask again, right? So now count becomes count plus 1 because we've asked again. Now, let's run this code. Count becomes 1. Let's say we put in a -1, which is outside of this range. Then column becomes input prompt, we ask again. We put a -1 again. Count becomes count plus 1. If count is equal to 4, it's not. So we'll end, we'll hit this again. We'll still put in a -1, right? So we'll have to do it again. Count will become 3, run again, count will become 4. Now, what if on the 4th time they actually enter something correct? But it'll still run this, right? Count is 4, we've asked 4 times, but what if on the 4th time they input something correct? We don't want to produce a warning, right? It's right. So what we also need in this if statement is an and column is less than 1 or column greater than dim at 2. This is basically checking that same condition and that count equals 4, right? And then all you'd have to do is produce a warning. I don't think they put warning here. Invalid, just put invalid column setting to 1. So I just put that because that's what I felt like it would say. And then column, we'll force set column to 1. And then once the if statement ends, we'll bounce back up. Column is now 1, which is inside this range, meaning we just finished the while loop. This is one way to do it. I'm going to go ahead and copy and paste this out, and we'll work on this now from the way Justin was saying earlier. Let's actually go ahead and throw this below here so you can see this one. Okay. So, like we said before, we have to set count equal to 1 if we've asked once, right? While column is less than 1 and column is greater than or equal to dim, we got to ask again. We keep adding 1 to count every time we ask for it, right? Now, we want this while loop to keep asking until we hit count equals 4, right? And so we need an and here. Count is less than 4, right? So I ask once, count becomes 1. Let's say we enter a -1, so it doesn't meet this condition, so we'll bounce back into here. Enter a -1, again, count becomes 2, hit the while loop again, still doesn't meet this condition, ask again, we'll put a -1 in, count becomes 3, and while loop again, ask again. This is now the fourth time we're asking. Enter a good value now. Enter a, let's we enter 1. Count becomes 4, right? So now what happens is count is now 4, right? So we bounce out of the while loop no matter what, right? Because it's no longer less than 4. Outside of this while loop, we'll now need if column is less than 1 or column is greater than dim at 2, right? Because now outside of this while loop, once we asked 4 times, we want to then test one more time if it is still outside of the range. If it is outside of the range, we add that warning, right? And then I'll just grab this because this is what it was. No. Put it right there. Cool. Awesome. So that's how we would do it Justin's way. Um, the whole idea here is you have to have these parentheses around this condition because you want to test this condition first. So for example, let's say I enter a value that is less than 1, right? If the value is less than 1 or greater than whatever the dimension is of columns, then I want this statement to be false. This whole statement, meaning that I want my while loop to run. You think of it as like if this is not correct and this is correct, this entire statement will still be false because we're using an or, right? And vice versa. If this is incorrect, but this is correct, this statement will still be false because we're using an or, right? Only one of them has to be false for the whole thing to be false. That's how ors work. Now, for the and, both things have to be true in order for us to skip or run the while loop, right? If one of them is false, that means we don't have to run the while loop, right? So that's why we have to use an and here, because once both of these are true, meaning that we have to use an or there, and count is less than 4, we'll keep running it. Does that make sense? Awesome. Awesome. Cool. So, and then the last thing is just simply once we finish that while loop and count is equal to 4, we'll just have to do it again with an if statement just to make sure, one more time, make sure that it's inside the range. If not, just warning, set equal to 1. Um, After that, it seems like we just apply the function. So it's simply just, I don't think I have saved it. Yeah, cool, this is an old one. So I'll just use, I'll just do changes here. Becomes change column of imat. So mat's going to be mat, like we did up here. And then column is going to be column. And then it simply just wants us to save it to a .mat file, which is again exam2 changes.mat. And we want to do changes. Right? Boom. Changes was again what we came out of the function with, right? Well, it's what we did earlier in that function. Remember how like the whole idea was we had those changes, right? But we needed but what we're doing now is just simply giving it the matrix and giving it the column that we want to perform those changes on. And like we said last time, Justin, the whole idea here is you use the function, the brackets here, to define it, but to call it, all we did was just use the name inputs and then assigned it to an output. So calling it is like using it, defining it is actually defining what exactly is going on inside the function. Cool. But that's the whole problem. I'll go ahead and sit here for a couple more minutes if you guys have any questions or need me to walk through any of this again. I'm going to try to comment on the code as much as I can before I put it on Discord, so or YouTube or YouTube and Discord, so you guys can see what's going on. But otherwise, yeah, I'll take any questions if you guys have any. Let's start with questions about these two prompts here, and then I'll go ahead and stop the recording so we don't waste anybody else's time while they're trying to watch the video. Okay. Mm-hmm. Yes. So if you're indexing a column, so for example, in this case, remember how new call is already a column vector, right? It's a vector. It's a one-dimensional. It just has like rows, right? So when we index that vector at I, we're pulling out some at of certain value at a certain row, right? Because it's a vector. It's not two-dimensional. But then if we index the matrix like here, like we're doing at count, like pretend count was a for loop, we have to make sure that we put in a second column value, right? Because we have a two-dimensional space there, right? We have rows and columns. Yeah. So if it was originally a column vector and you're indexing that column vector with a single value, you'll only pull out a scalar value. So for example, if I have so like you mean right here? Like something like this? Or like something like this? Okay. Okay. So remember how yeah, it's just switching it, right? Because remember how we had let's say new call becomes I'm just saying mat at, let me just define a vector for us real quick. Okay. So imagine this is new call, right? If I is 3, I am taking this guy and I'm comparing him in some way, and then I'm replacing this guy, new call at I, with the average of these two values, right? So the average of these two values, since these two values are scalars, is also going to be a scalar on this side, right? So we're assigning a scalar to new call at I, which is new call at 3. So you're just replacing it, like you said. You're just replacing that one single value at I. Yeah. So for example, if you wanted to like add a value after this, is that what you're saying? It's like yeah. So for example, if we had a different oh, I see what you're saying. Yeah. Yes. If it's already a column vector and you were to say like a new call at I plus 1 becomes something, as long as that something is a scalar, it'll automatically add it to the end of whatever vector you have here. So if it's a row vector, it'll add it to the end of the row vector. Yeah. And that's only if I is equal to end, right? End plus 1, right? Because we have to do the last value. Yeah. But if you always have a single index, it'll always move along that direction of dimensionality that your vector is on. So like I will always move down the vector no matter what, as long as it's a vector. Cool. That's a good question for sure. Any more questions about the problems we went over? No. Cool. I'll go ahead and stop the recording, and I will